Here, bringing you the IM3-6-2 extra practice number 3 solutions on multiplying and dividing rational expressions. In this one, we have a puzzle to solve, so let's go ahead and see what that's about. So here's the puzzle that we're supposed to solve. We're trying to solve the riddle, what do you call a message printed on a lion with chickenpox? And to solve this riddle, we have to solve, or actually just simplify these expressions here, these 10 expressions. And whatever letter the answer is for one of these, we just put that letter next to the number down in the box below. So for example, if I do number 1 and I find that the answer is H, for example, I don't know what it is, but maybe that's it, then I would put an H next to the 1 right here, or whatever letter it was. So let's go ahead and see where this one leads us. All right, here we go with problem number 1. We're trying to multiply these rational expressions together. So there's a few ways we could do this. We could start reducing, cross-reducing, as it were, before we multiply anything. And usually I would do that, but in situations like this, where I don't have anything that's going to need to be factored, sometimes I just like to multiply it all together so I only have to reduce once. So multiplying my numerator together, that's going to be 6x cubed y to the 4th, if I just put it in alphabetical order. And now down here, we're going to have a 2, an x, and a y to the 3rd power, 2 plus 1 for the exponents. Going through and reducing what I can, the 6 over 2 reduces to a 3 over 1. X cubed over x, those are going to reduce, subtract the exponents. We've got an x squared in the numerator. And then y to the 4th over y cubed, that reduces to give me just a y to the 1st upstairs. So let's see what I've got left over. In the numerator, I have a 3, an x squared, and a y. And in the denominator, I have a whole bunch of nothing. I crossed off everything, which means I still have an invisible 1 down there, although I wrote the 1 here anyway. So let me see if I can find that in my answers. It looks like it actually is H. I didn't even know I was picking the right answer for my example of how to do the puzzle. So we will actually put an H under spot number 1. Hey, there we go. For number 2, I'm going to start this one by multiplying everything out, and then I'll just reduce whatever I get. So for my numerator, we have 5 times 8 for 40. We've got x to the 4th, so 40, and then x to the 4th. And then we have y squared times y giving me y cubed. In the denominator, I'm going to have a 60, and an x squared and a y to the 5th that don't change. Going through and reducing, 40 over 60 reduces to 2 over 3 if I reduce that by 20s. X to the 4th over x squared, that reduces to an x squared, 4 minus 2, in the numerator. And then the y's, those are going to reduce as well to a y squared, but now that's going to be in the denominator because I had a larger exponent in the denominator to begin with. So what do we have? We have a 2 and an x squared in my numerator. And in the denominator, we have a 3 and a y squared, so 2x squared over 3y squared, which is going to give us D right here. So that goes in spot number 2. And we got to be careful because some of these have multiple spots. There's another 2 over here that also gets a D. Here we are on number 3. Now it's looking like I'm going to have to do some factoring in this one before I'm going to see anything that's going to cancel out. So let me take a look at my first fraction. In the numerator, I have factors of 12 that add up to 7. 1 and 12 doesn't work, neither does 2 and 6. 3 times 4 equals 12, and 3 plus 4 is 7, so x plus 3, x plus 4. I'll leave the x minus 5 down there for now. And over here with 2x minus 10, I can take out a 2 from that. That leaves me with an x minus 5. And again, we still have that x plus 3 hanging around there. Going through now, let's see what I can cancel out. And for all these problems, if I have multiplication, then if something is in the numerator of one fraction and the denominator of another that's being multiplied, like these x plus 3's, I am allowed to cancel those out. Because remember, we could actually just multiply this all together, tops by tops, bottoms by bottoms, and get one big fraction anyway that had this x plus 3 and this x plus 3 in it. So those cancel out. X minus 5's here can cancel out. So that leaves me with a 2 and an x plus 4 in the numerator, nothing in the denominator. So just 2 parentheses x plus 4. No need to distribute that. It's in one of the answer choices here anyway. So that's going to be an E going in spot 3. and another one over here for this spot 3. For this next problem, let me try factoring both fractions as much as I can before I start crossing things off. So for the first fraction, numerator, I need factors of -10 that add up to -3. 1 and 10 doesn't work. 2 and 5 works if I have +2 and -5. So x plus 2, x minus 5. X plus 7 is still down there. Haven't done anything with that yet. And then for the other fraction, in the numerator, I can factor a 3 out of both of those terms, leaving me with an x plus 21 divided by 3 is 7. Down below, we have a 6 coming out of there, leaving me with an x and a minus 5. Going through and canceling out now, these x minus 5s can cancel, and then these x plus 7s as well. And then I notice we have a 3 and a 6. Those can reduce to give me a 1 over 2. So cleaning up the mess in the numerator, we have just an x plus 2 really. And in the denominator, all that's left is this 2. So x plus 2 over 2, and we know that we can't cancel these 2's as much as we would like to because we can't separate them off into their own fraction. So x plus 2 over 2 is I. That goes in spot 4. And there's actually another 4 all the way over here, so we get another one where we get 2 for the price of 1. Number 5 is a little bit tricky. There's not much you can do to factor this, except that this 1 minus x can be tweaked a little bit. I don't like the order that that's in, so I'm going to take a negative out of that to reverse the order of subtraction. So if I take out a -1, that leaves me now with a positive x and a minus 1. All right, let's cancel what we can. The x minus 1s definitely will now cancel. And I can reduce as well. 6 and 4 reduces to a 3 over 2. X squared over x, that reduces to x to the first power up in the numerator. And y and y cubed, that reduces to y squared down in the denominator. All right, what's left? In the numerator, well actually overall, we have this -1 here, so that makes the whole fraction negative, first off. Then we have a 3 in the numerator, and we also have this x to the first, so 3x. Denominator, we have a 2, and it looks like we still have a y to the second power, so 2y squared. And that's all going to be this first one, option G. So let me put that in spot number 5, and there's no other spot 5s, so we move on. All right, here's the next one, number 6. Let's see what we can do here. I think we should try factoring this one before we start crossing anything off. I mean, we could start reducing the 13 and the 26 here, but let's just factor everything, get all our cards on the table. So first fraction, the numerator can't really be factored, but the denominator, factors of -18 that add up to 3. Well, let me think. 1 and 18, no. 2 and 9 doesn't work. 3 and 6 works with a -3 and a +6. So x minus 3, x plus 6. And then moving on to the next fraction, this x squared minus 9, I can split that up with square rooting. So x plus 3, x minus 3. And then that 26 and everything else is the same down there. So let me go ahead and start reducing. 13 and 26, I can reduce that to 1 and 2. X and x to the fourth, that reduces to give me an x cubed downstairs. Y squared and y squared both cancel out completely. And then let's see, down here we have an x minus 3. That's going to cancel this x minus 3 out. And it looks like that's everything I can cross off. So collecting what's left over, in the numerator, there's nothing in the upper left here. There's still an x plus 3 over here, though, so that's my whole numerator now. And in the denominator, we have the x plus 6. We also have a 2 and an x cubed. I'll write that first, and then the x plus 6. There we go. I don't think we can do anything else on this one, so I'm going to go ahead and, let's see, that's going to be, where is that? Where do I see that? Right over here. It's the second column here. I was just looking at the first column, but there's a whole nother column over here. So that's going to be this one here, L. That's going to be choice 6, or option box 6 for L. There we go. Let's move on. For this next one, let me do a little bit of factoring first. My upper left here, I can take a -1 out of that to at least reverse the order and get the x squared first. So that'll be x squared minus 25 there. Denominator can stay the same there. Numerator over on the next fraction can stay the same. For the denominator, though, I can take an 8 out of that. That leaves me with an x plus 5. All right. I need to factor a little bit more, actually, with this x squared minus 25. So I have the negative 1 that I took out already. Now I can split this up using square rooting into x plus the square root of 25 plus 5 and x minus 5. Now what cancels out? X plus 5s are gone. X minus 5 is sticking around. This 14 and this 7 reduce to give me a 1 and a 2. X squared and x cubed reduce to give me an x to the first in the denominator. And y and y8 also can reduce to give me y to the 8 minus 1, y to the 7th down there. And this 8 is going to be hanging around. So what's left over? Well, this negative out in front here, this is going to make the whole fraction negative. So let me write that out in front. Now for my numerator, I have an x minus 5, and it looks like that's it. For the denominator, I have this 2, an x. We also have a y to the 7th. We also have an 8. So 2 times 8, that's going to give me 16. And then again, we had the x and the y to the 7th. So negative x minus 5 over 16, xy to the 7th. That's down here in the lower corner. So that's s, which goes in spot 7. So there's a 7. And it looks like that's it for 7s. So on we go to number 8. So for this one, we kind of hit the ground running right away here. This craziness that we have to factor in the upper left, let's go ahead and take care of that first. So for this, I'm going to use the AC method. There's no common factors I can take out. 2 times negative 7 gives me an AC value of negative 17. So I'm looking for factors of negative 17, or negative 14, I should say, that add up to 5. So that would be, let's see, 1 and 14 doesn't work. 2 and 7 works if I have negative 2 and positive 7. So I'm going to split this 5x up into a negative 2x and a positive 7x. And now since I have 4 terms, I can use grouping to factor this. For the first 2 terms, I can take a 2x out of those. Leaves me with an x minus 1. For the next 2, I can take out a 7, so far not so bad. Leaves me with an x minus 1 again. That means x minus 1 is one of my factors, and 2x plus 7, the leftovers, is the other factor. So let me rewrite this numerator now as x minus 1, 2x plus 7. Still have a denominator of x plus 4. That hasn't changed. Over in the next fraction, in the numerator, I can take out an x. That leaves me with x plus 4. And I can factor that denominator as well. We have a perfect square sandwich here. So if I square root these, I have an x, and let's see, since my middle term is negative, I'll make that a negative square root of 1, negative 1, whole thing squared. Now just to double check, if I multiply x and negative 1 together and double it, I get the negative 2x that I started with, so I did actually factor this correctly. Good to know. Now let's see what we can cancel out. I have an x minus 1 here. I have 2 of these x minus 1s down here. So I can cancel out one of those. I'll just cross off the 2. That leaves me with just x minus 1 to the first power down there. 2x plus 7, can't really match that up with anything. But this x plus 4 and this one over here can also cancel. So the numerator, I've got an x and a 2x plus 7. Denominator, just this x minus 1. And all of that is going to be this n right here. So we put an n under 8. And there's another 8 right here that gets an n. And there's another 8 at the very end that gets an n. There we go. We got a lot of mileage on that one. Here's number 9. This one's a little bit intense. It turns out that every single piece of each fraction can be factored in some way. Let's start in the upper left and work our way over. So we've got a 2 that I can take out of the 2x plus 10. That leaves me with an x plus 5. And then I'll just do the denominator while I'm at it. So I can take out an 8 from both of these, but I'm going to do a little better than that. I'm going to take out a negative 8. That lets me get the x first on the stuff inside here. So that leaves me with a positive x minus 4. Next up, upper right, factors of 24 that add up to negative 10. We could try 1 and 24. That doesn't work. 2 and 12 doesn't work. 3 and 8 doesn't work. 4 and 6 works if they're both negative. So x minus 4, x minus 6. And now down below, factors of negative 30 that add up to negative 1. 1 and 30, no. 2 and 15, no. 3 and 10, no. 5 and 6, if I have positive 5 and negative 6. So x plus 5, x minus 6. That'll add up to my negative 1 there. All right, let's reduce and cross off whatever we can. The 2 and the 8 clearly can reduce to 1 over 4. X plus 5 up here and down here, those are canceling. This x minus 4 and this x minus 4 can go away. And then these x minus 6's were in the same fraction even, so those are gone. So what's left? Well, our whole fraction is negative because we still have an unresolved negative down here. In the numerator, I have everything crossed off except for this invisible, not so invisible 1. And then in the denominator, all that's left over is this 4. So negative 1/4 when all is said and done. Pretty easy to spot that in my answers. That's right here. That's t. So 9 gets a t, and you get a t, and you get a t. And we're left with just one more problem. All right, here we are, final problem. Let's see what we can make of this one. So a whole bunch of factoring going on in this one in pretty much every part of the fraction. So let's start with the upper left. We can take a 12 out of both of those. So we have an x plus 4 left over if we do that. In the denominator, we can take a 3 out of the 6 and the 15. So that leaves us with a 2x minus 5. Over here on the right side now, we have two perfect squares. If I square root those and use my plus minus, square root of 4x squared is 2x. Square root of 25 is 5, so 2x plus 5 and 2x minus 5. And now here we need factors of 20 that add up to 9. 1 and 20 doesn't work, 10 and 2 doesn't work. 4 and 5 works if they're both positive. So x plus 4, x plus 5. All right, what can I cancel and reduce? The 12 and the 3 reduce to 4 over 1. And then we also have the x plus 4s can cancel. These 2x minus 5s can cancel. This one and this one over here. Just make sure you canceled the right 2x and the 5 there. And then it looks like that's just about it. So what's left? The numerator, I've got a 4 and a 2x plus 5. In the denominator, it's just this x plus 5. And all of that stuff is, almost here. It's not this one. This says 2x minus 5. I need 2x plus 5. Sneaky, sneaky. And the bottom is also a little bit different. Let's see. There it is. Right there. We got an O right here. So that's going to be going in spot 10. So right there, right there, right there. And now we are ready to go ahead and solve the puzzle. So now we're solving the riddle. What do you call a message printed on a line with chicken pox? And the answer, reading through here, we have sign on the dotted line. Sign on the dotted line. I get it. Till next time, Mr. Sutton signing off. But not on the dotted line.